Hello everyone. Today we'll be talking about blockchain and hash functions. So basically blockchain, as the name suggests, is a chain of blocks. These blocks have special properties, but- and hash function is more what makes them so special. So every block has some information and has its own hash, and uh, its own hash and the hash of the previous block. So block one, block two, block three. So so for example, this block 2 will have the hash, which will have its own hash and the hash of block 1, and block 3 will point to block 2. This is what exactly connects them to a chain. So let's get further into hash function. Hash functions are basically fingerprints of data. Fingerprints of data. They are what help us to identify data and compress them. So any amount of data can be converted into a fixed length of hash function. A hash function has six properties. First one is it's deterministic. So what this means is that no matter how many times you input the same data, you'll have the same output. You'll have the same hash function. It is a really critical property because if you get different hashes every time, it's impossible to keep track of the input, right? And the other one uh, is it can calculate, however, it's quick computation. So a calculation of a hash function needs to be really quick and really efficient. That's what makes a blockchain really efficient. The third one is, and it's a really important one, it's pre-image resistance. Pre-image resistance it means that it's infeasible. Notice how I'll explain why I use the word infeasible instead of impossible. That it's infeasible to to get the data from a hash function. To guess the data from a hash function. For example, take a dice. Dice, given a dice has six types of inputs, right? So you're given a hash, and you're expected to tell what number, uh, what number this hash stands for. So you'll have to calculate hashes of all six numbers, and then um, um, match match the hash. But in Bitcoin's case, or in other cases where the data is basic is in a very large amount, it's infeasible to calculate what to calculate or guess the hash what the hash what data the hash stands for. And the fourth one is a really important one. It's basically that a small change in the data will lead to a whole different output. For example, if you take a name that is my name, and if you add it will have an hash function, and if you add an exclamation mark to it, it will have a whole different hash function. So there's no way that you can guess or get to um, or get to the data or get to my name with the hash function. That is a really important component which makes it a hash function pre-image resistance. Uh, the fifth one is collision resistance. What it means is that there are no two data there is no two data two inputs which leads to the same hash function. Well, practically, not practically, well, theoretically, no hash function is collision resistant. But but because of the enormous amounts of hash functions and the infinite inputs, this it is really infeasible, like pre-image resistance, to find a collision. So it takes so long that it doesn't matter. The sixth property is a little complicated. It's called puzzle friendliness. So basically, if this h k x is equal to y, h is there's this data and there's this output, that is y. There's the hash of this data. So basically, if you have the output, if you have the hash, and you have if you have the data, if you have a part of the data, there's no way you can calculate the rest of the data. It's really it's a little complicated. So, so how does this whole thing relate to blockchain? So suppose there is a blockchain. There is a blockchain, and someone goes and makes a little tweak in the hash function of this blockchain. What will happen is this block will change will have will this block's hash will not match this block's previous hash, right? Will not match the hash of the previous block, right? So this will lead to all the blockchains getting corrupted, and this will ultimately break the blockchain. So that is exactly what makes a blockchain immutable.